I'll be going over question 9 from sample final number 3. So we're given the following letter choices, and we are asked whether or not which of the following letter choice has a binomial distribution. So let's recall what the 4 conditions for binomial distribution are. So we have 2 outcomes that we're interested in. So yes or no response. And then the second condition is independent trials. The third one is a fixed probability of success and failure. And then the last condition is a fixed sample size drawn from the population. So let's check each letter condition. So let's look at letter A. We roll 5 dice, each one with face value of 1 through 6, and X is going to be the total number of dots facing up on the 5 die. So our sample size here is 5. And then if our X is going to be total number of dots faced up on the 5 dice. So let's say if we have if X is equal to 6, right? So total number of dots faced on the 5 dice is 6. That could be 4 dice with 1, and then the last one is with a face value of 2. So if I do 5 choose 6 with n is equal to 5, that's not possible because I cannot choose 6 objects from 5. So for example, if I had 5 oranges, I can't pick 6 oranges from 5 because there's only 5 objects there. So A is not a choice. So B, you monitor the weather stats every Saturday in Winnipeg. So we're interested in the number of Saturdays that snow. So our probability of success here will be the Saturday that it snows. And then the failure will be a Saturday that doesn't snow. So we notice here that the probability that we have a Saturday that snows is not constant. So it changes each week. Therefore, it cannot be a binomial distribution. Letter choice C. So we have a paper boy delivering newspapers at every house on each block. So we're interested in the number of houses that get the newspaper on time. Again, we don't have a fixed sample size n here. So n will be the number of houses in the neighborhood in each block. So since each block of the neighborhood has a different number of houses, we don't have a fixed sample size to draw from, so C is false. So letter choice D. We repeatedly flip 2 quarters simultaneously until we arrive at 2 heads. Now we notice here that our sample size of n is a random variable that can take on an infinite support, so it's not fixed. So D cannot be a right answer, which leaves us with letter choice E as the answer. But let's verify the 4 conditions with it. So fixed sample size here for a 30 multiple choice question. So n is fixed with 30. A probability of success here is if the student gets it right, so that's 20%. If the multiple choice question has 5 choices, 1 over 5. So that's satisfied. We have independent trials. So me guessing on the first question will not change the probability of guessing for the second question. It will still be 20%. And then the last part with 2 outcomes, we can either have getting the question right or the complement of getting the question right, which is getting the question wrong.